Hello and welcome back to my channel. Today I will be solving problems 4 and 5 from the IMO. Now, the problem 4 is a number theory problem. It's simple. A1, A2, and it's an infinite sequence of integers, and it needs to be infinite. We need to find all A1 such that the sequence is infinite. And the catch is for each n greater than or equal to 1, an plus 1 is the sum of three largest proper divisors of an, where a divisor is called a proper divisor if it's less than n. Okay, now first I claim that a1 needs to be divisible by 2. If it isn't, then its largest three proper divisors, call it b1, b2, b3, these divisors, they will all be even. I mean, they will all be odd if a1 is odd. So a2 will be odd, and so on. Everything will be odd. But it's a contradiction because an plus 1 is less than an times 1 over 2 plus, 1 over 3 plus 1 over 5 plus 1 over 7. And this is less than an. So it will be a strictly decreasing sequence, which is a contradiction. Now I claim a1 is divisible by 3. Suppose not. Well, if a2 will be a1 over 2 plus a1 over some a plus a1 over some b. Now, this is a contradiction because suppose this is divisible by 3. Then it means that 1 over 2 plus 1 over a plus 1 over b is divisible by 3, following that a and b are congruent to 2 mod 3. But this means that v2 of a1 is 1, because if a1 is divisible by 4, then one of a and b will be 4, but it isn't because they're congruent to 2 mod 3, which means that this is even too, and this is odd, and we get that a2 is odd, and the same argument that we used to help out. So we know that a1 is divisible by 6. Now suppose a1 is divisible by 5. Well, what will happen? Well, a2 will be 1 over 2 plus 1 over 3 plus 1 over 5 times a1. But well, suppose a1 is divisible by 5 but isn't divisible by 4. Well, if this happens, then this thing is odd, right? This is even, this is even, this is odd. So if it's divisible by 5, it must be divisible by 4 as well. So a2 then will be, if it's divisible by 4, it's this times a1. And this thing is 13a1 divided by 12. It kills 1 power of 3 and 2 powers of 2. Well, if it's still divisible by 12, it will still kill 1 power of 3 and 2 powers of 2. So if something like this happens, and we already proved that at all points it needs to be divisible by 6. So if a1 is divisible by 12, we need to keep this 6 here and have this. So if this happens, then we have 13 to the alpha times 6 times t by the end of all dividing by 12 operations, where t is an odd number. So, and here t cannot be divisible by 5 because we already proved it, and it also cannot be odd. It cannot be even, because then the powers of 2 would come down eventually to 1. Because it's always decreasing, it will eventually come down to 1, but it can't come down to 1 because then you'll have something like 1 over 2 plus 1 over 3 plus 1 over 7, because power of 2 is already dead, and it will lead to an infinite descent of numbers. Now, about the second problem. It's an inequality game where Alice and Bob are playing. Alice needs to choose numbers such that this always holds, and Bob needs to choose numbers that this always holds, where lambda is a given positive real number. Okay, well, suppose Alice chooses 0 in the start. That's how I started to think. Can Bob choose a number such that this is greater than lambda 2 lambda, and its square is less than or equal to 2? Well, this can happen when lambda is less than root 2 over 2. So suppose lambda is greater than root 2 over 2. And Alice has been choosing her numbers all along to be 0. So you have something like this. She chooses 0 still, and if some, so I'll prove that Bob can never win. So suppose Bob wins on some k. Well, this thing from quadratic mean arithmetic mean equality, this thing is greater than or equal. So suppose at some point it happens and this is greater than this and this still holds. Well, this is greater than or equal to what? The sum of xi's squared divided by the number 2k. No, not the number k. By condition, we know that it is lambda, n here is just 2k, right? So this here is lambda squared times 4k squared divided by k. This is strictly greater, and this is strictly greater than 2k squared divided by k, which is k, which is just 2k. So you get 2k needs to be strictly greater than 2k, which is a contradiction. So Bob can never win. And after some k, Alice can choose a number x equals x times 2k plus 1 equals lambda times 2k plus 1 minus the sum of these. And this will work because after some k, after large enough k, this thing will be greater than root 2k. So that's 2k plus 1. Now let's suppose root 2 over 2 is greater than lambda. Well, now Bob will choose a strategy like this. When Alice picks an x, Bob will choose this number. Well, if at some point xi is greater than root 2, Bob wins on the spot because x. So let's just suppose he's been doing this strategy. Well, without lots of generality, we can assume x1 is greater than root 2. And if this happens, then the game's already done because this is greater than lambda, right? And lambda times 2. And Alice has already lost. And so you have something like xi plus root of 2 minus xi squared plus something like this. This is, and we know that this is at some point less than or equal to lambda times n. Well, this thing, if we look at it, this is always greater than or equal to if we plug in 1 there. So this is just, this thing is always greater than or equal to 2, right? And, well, for Bob, the condition always holds because you have xi squared plus root over 2 minus xi squared plus something like that, right? And this needs to be less than root 2 over 2 times n. And so this is always greater than or equal to root 2. And Bob will never lose because this is just always equal to 2 times k, and this is equal to n. So Bob will never lose, and Alice cannot win because since this is strictly less than root 2 over 2n, and this is strictly, not strictly, but greater than or equal to root 2 times n over 2. At some point, Alice will be forced to choose a number that's large enough, and this will not hold. And if lambda is equal to n over 2, root 2 over 2, they both can just spam their strategy and none of them will lose, so it will end in a draw. Thanks for watching. See you next time.